This module introduces an important statistical tool, the hypothesis test. We're going to do so by looking at a simplistic example. I want you to contemplate this coin. Now, this coin is not just any coin, and not only because it represents the sum total of my life savings. No, this coin has been nominated by the National Football League to be used for the opening coin toss in this year's Super Bowl. You see, the NFL is scrupulously concerned that the opening coin toss be scrupulously fair for both teams. And so every year they bring in a respected outside consulting firm to validate the fairness of the coin toss. And this year, Stetson University, because of the prominence and reputation of its statistics program, we have landed the gig. And so the question for us today is this a fair coin? Well, what do we mean by a fair coin? Well, Dr. Raspayer, you say, it's one where we got a 50-50 chance of getting heads or tails. Yes, if we think about it just a little bit further, we'll realize not only is it 50-50, but each toss needs to be random. What happens on one toss doesn't tell us about or affect other tosses. Let's face it, the sequence heads, tails, heads, tails, heads, tails, heads, tails, heads, tails, heads, tails is pretty suspicious, even though it's 50-50. So fair coin, 50-50 chance randomly. Next question. How do you propose that we go about deciding whether it's a fair coin? Well, Dr. Rasp, I guess we're just going to need to go toss that coin a whole bunch of times. That is actually a profound statement in the history of science. It is. I'm being serious here, and that doesn't happen very often. In other words, in technical terms, we are going to be empiricists. We are going to rely upon empirical, experimental evidence to decide whether this is a fair coin or not. And we've decided it needs to be a whole bunch of tosses, not just 3 or 4. The actual number of tosses, that's a somewhat involved technical question, and we'll defer it to later. But let's say we're going to toss the coin 100 times. Next question. Thought experiment. If we toss the coin 100 times and get 99 heads and 1 tail, do you think that's a fair coin? 99 heads and 1 tail. Dr. Rass, there's no way that's fair coin. Well, why not? That's nowhere close to the 50-50 we would expect. Now, wait a minute. Could a fair coin give us 99 heads and 1 tail? Well, yeah, I guess it could, but it's pretty unlikely. And if it starts happening, I'm going to start buying lottery tickets. So, 99 heads, 1 tail, nowhere close to 50-50, very small chance of happening. We don't think the coin is fair. Sounds reasonable so far. What if we got 51 heads and 49 tails? Is the coin fair? Yeah, I'm willing to believe that's a fair coin. Wait a minute, that's not 50-50. Yeah, but it's pretty close. And it wouldn't be all that unusual for a fair coin to give us 51-49. So, 51-49, pretty close to 50-50, not all that unusual event, we're willing to believe the coin is fair. What if we get 90 heads, 10 tails? Nope, don't think that one's fair. 53-47. Yeah, I'm willing to believe it's fair. 80-20. 57-43. 60-40. Notice what's happening here. Somewhere between that 99-1, we're pretty sure it's not fair, and 51-49, we're more than willing to believe it's fair. There is a point somewhere along that continuum where we're going to change our mind. Some results will cause us to believe that the coin is not fair. And from some results, we're willing to continue believing that the coin is fair. The question is, where is the boundary line between those two universes? That's an excellent question, and that's the topic of the next video.